okay? So here's what we're going to do. We're going to take a look at a kind of a complicated graph, and then we are going to use that graph to find out where it's continuous, where it's not continuous, and also define the intervals where it is continuous. So what I'd like you to do is let's draw a sketch that looks something like this, okay? We're not going to have a lot of positives and negatives and things like that. So I'm going to draw the graph here in purple. So the graph is going to come kind of down like this. There is going to be a hole here, and this is going to be at 1, and this is also going to be at 1. And then the graph is going to go up like this at 2. Okay, but there also is going to be a point right up here at 3. Okay. Now, beyond 2, we're going to go to 3 here, and then this graph is going to kind of come down and go like this. There'll be a closed dot there, and then we're going to go, that's at 3. And we're going to go over to 4. There's going to be a hole there. And this is going to be up at 2. And then right down here, we'll have a closed dot. And this is at 4. And then it's going to go down like this. Okay? So this is the graph of f of x. Okay? So let's talk about different portions of this graph. So first of all, let's just take a look at where it is continuous, okay? And then we're going to look at some different spaces, and we're going to talk about why things are discontinuous. So let's just talk about where it is continuous. So from, and let me use green again, from anywhere before this graph, actually, let's just put an endpoint right here. So it is continuous between here and here. Okay, so from this negative value to 1, it is continuous because you can draw it without lifting your pencil. Okay, now at 1, we know something weird is happening. Okay. So we're going to talk about that a little bit later. Now, between 1 and 2, this portion of the graph is continuous. And why is that? Well, from just a little beyond 1 all the way up this way, you can draw that line without ever lifting up your pencil. Okay? Then you'll notice something weird happens at 2, and you should notice what it is. It is a vertical asymptote. So there's a vertical asymptote at 2. Now, it is also now continuous beyond 2 all the way to 4. This portion of the graph is continuous. Even though there's a dot here, you still just draw your line through there and you go all the way to the open space. Now you'll notice at 4, you have to lift your pencil, and then you draw the rest of it. So after 4, this part is continuous, okay? So we are going to look at the weird spots, okay? So let's talk about why it is not continuous at 1. So let's show why it is not continuous at x equals 1, okay? So this is going to be the first thing that we're going to do, and we're going to use the definition. So the first thing is we need to show the limit as x approaches 1 from the left of f of x. So go to your graph and take a look. As we come from the left, you'll notice that that value is 1. Now, you also need to show the limit as x approaches 1 from the right of f of x. Well, come in from the right. You'll also notice that this is 1. Okay? Now, this is the kicker, okay? What is f of 1? Well, if you look at f of 1 actually has a different value. F of 1 is 3. So why is this not continuous? This is not continuous because the limit as x approaches 1 of f of x does not equal f of 1. Okay? That's how we show that things are not continuous. You have to use all three parts and show that they are not the same. Okay? So let's take a look at the next one. Okay? The next place that it is discontinuous is number 2. And that is, it is not continuous at x equals 2. Let's explain why. Okay? So let's look at the limit as x approaches 2 from the left of f of x. So let's go up to our graph. So I'm going to just slide the graph up. And now we're coming at 2, but we're coming at it from the left. So notice I'm just tracing the graph all the way towards 2. And you notice it goes to positive infinity. Okay? Now, let's find the limit as x approaches 2 of f of x from the right. Okay? So let's go back up to our graph. Come in from the right side. Notice that I'm going to trace the graph from the right. And you notice that this one's also going to positive infinity. So far, it appears to be continuous. But the kicker here is what is f of 2? Okay? Well, look at the graph. F of 2 has a line there. That means it is undefined. So f of 2 is undefined. So this is not continuous at x equals 2 because the limit as x approaches 2 of f of x does not equal f of 2. They are not the same. Okay? So let's take a look at our last and final place where it is not continuous. Now I'm going to need to flip back and forth from my pages, so don't worry about it, but let's take a look at the last ones. So the last one is at f of 4. So number 3, it is not continuous at x equals 4. Okay? So it is not continuous at x equals 4. So let's go through and let's look at our key things. Let's find the limit as x approaches 4 from the left of f of x. So let's flip to the other side and let's go to 4. And as we come in from the left, you'll notice that the value that it's heading towards is the value of 2. Okay? Now, let's look at it from the right. So the limit as x approaches 4 from the right of f of x. So let's flip to the graph, and let's come in from the right. So we come in from the right side. This value is actually 1. Now, we do want to show all three parts, even though right now we can tell it's not continuous. Let's talk about f of 4. As we approach f of 4 here, your closed dot is at 1. So it is 1. So notice on this case, we have the limits are not equal. So this is not continuous because the limit from the left at 4 does not equal the limit as x approaches 4 from the right. Does not equal f of 4. So those things are not equal in any way, shape, or form. So this is what it means to be not continuous. Now, the reason I spent a lot of time on not continuous is because if you understand why it's not continuous, you know when it is. So I hope that video helped to give you some understanding of the definition of continuous and what that actually means. I also hope that this example of showing you where it is and where it isn't kind of helps you out. Now, let's, our next video, what we're going to do is we're going to talk about the types of discontinuities. So we will relook at some of these. I'm also going to focus then on intervals because I think this video is getting a little too long. So next video will be on types of discontinuities and how we define the intervals where it is continuous. So I hope this helps, and I will see you in the next one.